Very good morning, students. Am I audible? Am I audible, students? Okay, thank you. So today we start our new chapter, Unit 4, that is partial derivatives. Okay, and in this, today we learn about the function of several variables. Uh, see carefully. What is the unit name? Our unit name, that is Unit 4 as per the GTU syllabus, that is partial derivatives, and the topic name is function of several variables, right? So let's start with the first, the name of the topic, that is the function of several variables. So let me know, what about the function of one variable? Function of one variable. So I will give you one example for the understanding of the function of one variable, that is area of a circle. Area of a circle. Anyone give me the formula of the area of the circle in the chat box? Area of the circle. Yes, very good. Pi r square. Perfect, perfect. Okay. So area of the circle, that is pi r square. And in this formula, students, here pi is constant and r is variable. So this area of a circle, this is our function. Area of a circle is our function. And in this function, there is only one variable, that is r. Okay, so it means function of one variable. So if anybody asks to you, give me example of function of one variable, then you can easily say that area of a circle, that is pi r square. Another, area of a square. In square, length and breadth both are same. So that is area of a square. So let's move with function of two variable. Function of two variable. So what about the function of two variable? So let's take one more example, that is area of a rectangle. Area of a rectangle, and that is x into y. Suppose this is our rectangle, this one is x into y, and as you all know, length and breadth both are different here. So this is the area of a rectangle is our function, and this function with two variable, one variable is x and other one is y, right? Now function of three variable, then area of parallelopipe. Right? That is, suppose this one is our parallelopipe. X, y and z. So that is 2 times xy, yz plus xz. So there are three variables. So area of a parallelopipe with this function is with three variables. So students, if we have any function with two or more than two variable, listen carefully, any function with two or more than two variable is known as function of several variables. It is known as function of several variable. Okay, again I repeat, any function with two or more than two variable is known as function of several variables. Okay, now before going to start the partial derivative, First, we will move with the basic concept which we need for the partial derivative. So, if I ask you, what is the definition of the limit for the one variable? What is the definition of the limit for the one variable? See, is there anyone? Write in the chat box. If f of x is a function of x with limit x tends to a, f of x is equal to L for every epsilon greater than 0, there exists delta greater than 0 such that f of mod of f of x minus L, which is less than epsilon, where mod of x minus a, which is less than delta. Students, this is the definition for the limit. This is the definition of the limit for one variable. Similarly, if we convert or we can say with the help of this limit, we write the definition of the limit for several variables. That is, if f of xy is a function of x and y, and limit xy tends to ab, f of xy is equal to L, then for every epsilon greater than 0, there exists delta greater than 0 such that mod of f of xy minus L, which is less than epsilon. Here, x minus a less than delta and y minus b less than delta. So students, this definition of the limit for one variable which you learn in your school time in standard 11 and 12, right? So with the help of this definition, we are writing now the definition of the limit for the several variable, for the function of several variable. So see, compare. This is function with one variable. This is function with two variable. And as you know, any function with two or more than two variable is known as function of several variable. So this is f of xy. Here, limit, this is x tends to a. Here we have two variables. So x tends to a and y tends to b. F of x is equal to L. So here f of xy is equal to L. For every epsilon greater than 0, there exists delta greater than 0 such that as our function with two variables, so f of xy minus L less than epsilon. So mod of x minus a less than delta and mod of y minus b less than delta. So this is the definition of the limit for the function with two variable, or we can say function with several variables. Now we'll move for the existence of limit. Existence of limit. So this is the important for you. How to check the, if anyone asks, find the limit of the given function, then how will you check the limit of the given function? So there is a first step to check the limit, that is, if you have function that is with two variables, right, x and y, and xy tends to ab, then first to evaluate limit, with first limit x tends to a, limit y tends to be f of xy. This is your first step. Now, second step is limit y tends to be in the bracket limit x tends to a f of xy. Okay, this is your second step. So first, this is your function. First, you have to apply limit y tends to b. Then, whatever answer you will get, at that answer you have to apply limit x tends to a. That is first step. Second, first you have to apply x tends to a. Whatever answer you will get, at that answer you have to apply limit y tends to b. If your both answer 1 and 2 are same, if your both answer 1 and answer 2 are same, then limit exists. If both limits, if both the limit value are equal, then limit xy tends to ab, f of xy exists. Okay. So this is first rule. Now for the second rule, if second rule, sorry, if we want to find the limit at the origin, if what we want to find the limit at the origin, it means if a and b, a equal to 0 and b equal to 0, then again our first rule to find the limit, that is limit x tends to 0, here limit y tends to 0, f of xy. Number 2, limit y tends to 0, here limit x tends to 0, f of xy. Okay. Again, if both limits are equal, then there is another rule, that is we have to go for the different path. Okay. Evaluate limit with different path, and that path are y is equal to mx, y equal to mx square, up to y equal to mx raised to n. Okay, if all the values, if all the values are equal, then limit xy tends to 0 0, as a and b both are 0 0, f of xy exist. Okay, so still students, this rule is most important rule for you. So again I repeat, see, first rule for the finding the evaluation of the limit, that is if your a and b is not origin, they may be 1 2 3 4 minus 1 minus 2 any number but not origin, then for finding the limit, first you have to find the for limit y tends to be for your function f of xy, and then whatever answer you will get, you have to apply limit x tends to a. And for the other one, first you have to apply limit x tends to a, then you have to apply y tends to b. If both the answer are equal, then your limit exists. See, this AB is strictly here not equal to 0 0. If both answer equal, then your answer exists, limit exists. But for 0 0, but for origin, if both answer are different, listen carefully. If both answer are different, then limit does not exist. But if both answer are equal, then we have to go for the next path, that is y equal to mx, y equal to mx square, up to y equal to mx raised to n. If all values are equal, then we can say the limit exists. Okay, so this is the rule. Now we move with the example for applying this rule. Then after you will better understanding what I want to say. Okay, so let's start with the example, that is find limit xy tends to 1 to xy tends to 1 to x square plus y upon 3x plus y square. Okay, see, this is our question. Now for the solution, as our these are a and b, our a is 1 and b is 2, it means both are this point is not origin. Okay, this point is not origin, it means we have to apply our first rule. If both limits are equal, then limit exists. If both limits are different, then limit does not exist. Okay, so let's check. First one is here limit x tends to 1, here limit y tends to 2 x square plus y upon 3x plus y square. Okay, so limit x tends to 1. If we apply y tends to 2, so x square plus 2 upon 3x plus 4. Okay, now we apply x tends to 1 here, so 1 square, that is 1 plus 2. Here 3 into 1, see, this is 1 square, right? Here 3 into 1 plus 4, so this is 3 by 7. This is from the first. Now the other one, that is limit y tends to 2. Here first we apply limit x tends to 1, so x square plus y upon 3x plus y square. So limit y tends to 2, keep it same. After applying limit x tends to 1, that is 1 square plus y, here 3 into 1 plus y square, right? So 1 plus y and 3 plus y square. So if I apply y tends to 2 here, so 1 plus 2, 3 plus 4, that is 3 by 7. Both answer are equal. See, as I told you, see, if a and b both are not 0, 0, if both limit value are equal, then limit exists. It means here limit exists, and what is our limit? That is a limit for the given function at 1, 2 is 3 by 7. Therefore, limit exists, right? Okay, now we'll move for one more example, that is, students, have you any doubt in this example? Have you any doubt? If you have no doubt, please write no fast, everyone. I want the confirmation by all of you very fast. And if you have any doubt, then you can ask in the chat box. Okay. So, next example, that is find limit xy tends to 0, 0. Here x minus y upon x plus y. Okay, so let's start the solution. Our first rule, that is limit x tends to 0. Here we have to find limit y tends to 0, x minus y upon x plus y. Okay, so first we apply 0 instead of y. So limit x tends to 0. Here x minus 0, x minus 0 is x, and upon x plus 0, that is again x. So limit x tends to 0, both x will be cancelled, so equal to 1, right? So our answer is 1. For 2, limit y tends to 0, here limit x tends to 0, x minus y upon x plus y. Students, see carefully. If I apply 0 in the place of x, then the remaining term is limit y tends to 0. This is 0 minus y, that is minus y. 0 plus y, that is y. Both y will be cancelled out. So limit y tends to 0 minus 1, right? And the answer is minus 1. As our both answer are not equal, both answer are different, right? Both limit value are not equal. That's why limit does not exist. Understand? So, if both the limits, see, this is, we are checking for the origin point, right? So, if both limits are different, then in the earlier we can say that limit does not exist. But what happens if both limits are same, if this one is 1 and this one is also 1, then we have to go for the different path. If both limits are different, then limit does not exist. But if both limits are equal, then we have to go with the different path, and the path is mx square, like that. Okay, so have you any doubt in this example? Have you any doubt in this example? Okay, so we'll move with one more example, that is find limit xy tends to 0, 0, and our given function is xy upon y square minus x square. Okay, so let's start the solution. So our first step, as you all know, limit y tends to 0. Here, limit x tends to 0. Here, xy upon y square minus x square. So limit y tends to 0. If I keep 0 in place of x, then I have 0 into y, that is 0, y square minus 0. So 0 upon y is 0. So limit y tends to 0, here 0, our answer is 0. For the second one, second step, limit x tends to 0, here limit y tends to 0, xy upon y square minus x square, as limit x tends to 0. If we keep y 0, then x into 0 is 0 upon minus x square. But 0 upon anything is 0. So limit x tends to 0, 0 equal to 0. Students, here both limits are equal. Okay, but when we have to find the limit at origin at 0, 0, and if both limit are equal, then we have to go for the different path, and our third path, that is y is equal to mx. Okay, y equal to mx. This m is slope, so y equal to mx, as we assume y in the form of x. So our limit is limit x tends to, here x tends to 0 only. Okay, as y is equal to mx, so we have to take x tends to 0. So our third step, see carefully, limit x tends to 0, here x in the place of y, we keep mx, right, upon mx whole square, as this is y square, so this is mx whole square minus x square. So limit x tends to 0, this is mx square upon m, if I kept this is m square x square, so if I keep this x square as a common, this x square as common, then x square, and here m square minus 1, both x square will be cancelled out, and this m upon m square minus 1, as limit x tends to 0, but both x square will be cancelled out, so our answer is m upon m square minus 1, and m is not fixed here, m is any constant, so m is not fixed, m is not fixed means this value is different from the previous two, right? This value is m is not fixed. M is not fixed. It means this value is different from the previous two. It means limit does not exist. Okay. Any doubt, student? Any doubt? I know one question is there. If this is also 0, then what we have to do? Okay. So I will give you the answer in the next question for that. Okay. Okay. Students, 10 to 15 students are giving the response for the no doubt. What about the other one? I want the response from all of you. Okay. So let's move with one more example. That is, find one student has doubt. Ma'am, can we say that for m equal to 0 limit exists? No, Artika. If we take m equal to 0, then it means we can say that it is for the particular value. M is any variable, so we cannot say for m equal to 0 limit exists. Okay, we have to just, if for any m answer will same, then and only then we can say limit exists. Otherwise we have to just say that limit doesn't exist. Find limit xy tends to 0, x square y upon x raised to 4 plus y square. So our first path, this is our, we start the solution. At our first path, that is limit x tends to 0. Here limit y tends to 0, x square y upon x raised to 4 plus y square. So limit x tends to 0. Here y is 0, so 0 upon x square is 0 upon x raised to 4, right? Because x raised to 4 plus 0 is just x raised to 4, and 0 upon anything is 0. So limit x tends to 0 is 0. Answer is 0. For second path, limit, see here, y tends to 0. In the bracket, limit x tends to 0, x square y upon x raised to 4 plus y square, right? So limit y tends to 0. As x is 0, so 0 into y is 0 upon y square. But as you all know, 0 upon anything is 0. So limit y tends to 0, 0, answer is 0. So students, here both answer are equal, okay? And we have to find the limit at the origin. So we have to go with the different path, that is y is equal to mx, and taking x tends to 0, as our y is converted into the form of x. So we have to go x tends to 0 only, right? So third path, that is limit x tends to 0 only. Here x square, this y is mx upon this x raised to 4, keep it same, plus mx. So this is y square. So mx whole square, right? So limit x tends to 0. This is mx cube upon, this is x raised to 4, and here y square. So here m square x square. So if I keep x square common, so in the bracket x square plus m square, right? and both x square will be cancelled. 1x is left in the numerator. So limit x tends to 0. M into x upon x square plus m square. So if I apply my limit x tends to 0, then I have 0 upon m square, and 0 upon m square is 0, right? So again, the answer are same. Student, now the most important thing, we have to go for further or not. Anyone? Please write in the chat box. See, all three values are same. Then we have to go for y equal to mx square or not. Yes, yes. Many students are giving the answer that we have to go further, and you all are right. We have to go further because why? I will give you the reason. Because here, this is m square x square, okay? So when I substitute y is equal to mx, when I substitute, listen carefully, when I substitute y is equal to mx, the power of x square and the original power of x square are still different. This one is small, this one is bigger, okay? So we have to go for the for further, that is y equal to mx square and x tends to 0. So limit x tends to 0, here x square, here x square, and in the place of y I have to put mx square, okay, and upon x raised to 4. If I put here mx square, if I place in the place of y mx square, then mx square raised to 2. It means m square and x raised to 4. I think no one have doubt. Mx square whole square. Mx square whole square. It means m square and x raised to 4. Right? So this is, now the power of x are same. Okay, understand? So limit x tends to 0. If I keep x raised to 4 common, and in the numerator x raised to 2 into x raised to 2, that is x raised to 4. If I keep x raised to 4 common, then I have 1 plus m square. Now both x raised to 4 will be cancelled out. So now the remaining term is just m upon 1 plus m square. So this is m upon 1 plus m square. So which is here again, m is not fixed. M is not fixed. M is not fixed. It means limit does not exist. M is not fixed. Right? Therefore, limit does not exist. Limit does not exist. Now, what if we get the zero answer here? Listen carefully. What is if we get here 0, then here both the power are same and all the values are also same. It means limit exists. Then no need to move for the for checking another path. Okay. Here both the power x raised to 4 and here by putting mx square, the power of x are same. So then after no need to go for the another for the checking of another path, that is mx cube, right? So this is the answer. Limit does not exist. Have you any doubt, students? Have you any doubt? Please confirm in the chat box. If no doubt, then we'll move ahead. Okay. And please explain that again. One Mahir. Okay, Mahir. I explain again. See, Mahir. I think the first step is clear, right? The first step, answer 0. In the second step, answer 0. Then here, as we want to find limit at origin, so we take different path, that is y is equal to mx. And when we are taking y is equal to mx, we have to go with x tends to 0. So by substituting y is equal to mx in the place of this, our function. So when we put x square m into x upon x raised to 4, and in the place of y we put mx, so m square x square, right? M square x square. So in the numerator m into x cube, in the denominator if we keep x square common, then the remaining term is x square plus m square. Both x square will be cancelled out, one x is remain in the numerator. So after applying the limit, our answer is 0. So here three answers are same. This one is 0, this one is also 0, and this one is 0, right? Now we'll move with the next path, because when we substitute, Mahir, listen carefully. When we substitute y is equal to mx, then I have m square x square. It means here the power of x is square and here the power of x is 4. So both are still different. So I move with another path, that is y is equal to mx square. If this limit is different, then no need to check with different path. But this limit is same, it is equal. That's why we have to go with the another path. And this is by substituting y is equal to mx square, our answer is m upon 1 plus m square, which is different. Which is different? Here m is not fixed. M is not fixed. It means limit does not exist. But if this answer is 0, if this answer will be 0, then limit exists, because here both the power, here x raised to 4, this one is x raised to 4. So then we no need to move with another path. Okay, Mahir, got it? Mahir, confirm in the chat box. Now got it? Okay. So now this is the limit for the function of several variables. Okay. Now move with the next topic, that is continuity. Move with the next topic, that is continuity. So for continuity, three steps are there. Suppose let our function, let f of xy be a function of x and y. Okay, so it is a function of several variable. First, this given function is continuous or not. If we want to find the given function is continuous or not, then first we have to check f of ab exist. First we have to check f of ab exist or not. Okay, or we can say that f of ab, f of xy is defined at ab. What I mean to say, f of ab exists means our given function must be defined at the point ab. The second rule, that is, we have to find the limit xy tends to ab, f of xy exists. Means we have to find the limit of our given function at the point ab. And the third and the last rule for the continuity of the given function, that is limit xy tends to ab, f of xy, which is equal to f of ab, which is equal to f of ab. No, Dhruv, I have one another lecture.